Hello there, this is Geometry, Chapter 3, Section 3, Slopes of Lines. Most of you that are hating proofs right about now will like the fact that we're going to go into a lot of algebra today. There are a few theorems that we have, but a lot of this should be refresher from Algebra 1, and that was just last year. So, slopes. We have a slope formula, you probably remember it. It's right over here, and we use the letter M to denote slope. So change in y over change in x, other things that you probably remember, rise over run, all of those things, rate of change, all of those things are synonymous with slope. So the formula goes change in y, so y2 minus y1 over x2 minus x1, and the most important thing for you to do is label your points. Basically, when you're trying to find the slope, you have to be given two ordered pairs, 2 points, and we label those points x1, y1, x2, y2. And if you do that, then you'll never have a problem with finding your slope. Okay? So it says in example 1 here, we have A, B, C, D. Find the slope of each line. So each exercise, A, B, C, and D, are given a line. So the first thing we have to do is identify the points. So here I have J and K. And so J looks like it's going to be x is -1. And y is going to be -2. Alrighty. For point K, we're going to have 1, 2, 3, so x is going to be 3. And y is going to be 1, 2, 3 as well. Now it is very important when you label your points that you are consistent. It doesn't matter if I call this point x1, y1, or x2, y2, but I do have to be consistent. I cannot call this x1, y2. It has to be x1, y1, or x2, y2. No mixing x1 and y2, okay? So we're going to do that. We're going to call this one x1, x2, y1, y2, and to find my slope, we're going to get that slope is going to be, y2, which is 3, minus y1. Now when you have, this is always a minus, but if the y value is also negative, then you got to be careful when you have two negatives. It's minus -2, and on the bottom we have x2 is 3, minus -1, which again, you're going to have to do that. So, just be careful with that. So 3 minus negative is actually 3 plus. So 3 plus 2 is 5. And again, 3 minus negative is a plus, so 3 plus 1 is 4. So our slope is 5 over 4. So the rise is 5 and the run is 4. Alrighty, so now we'll just do that again. So we'll come over here now. And we're going to do the same thing. We need to find our points. So for L, so now we have L and M. L is going to be -1, -2. And then and then the y value is going to be 1, 2, 3. And then for M, the x coordinate is 1. And the y coordinate appears to be -3. Alrighty? But then we're going to do the same thing. We're going to get M equals y2, so we're going to do this again, and we're going to call this x1, x2, this is y1, y2, and then we're just going to follow the formula. The formula is just take y2, which is -3, and subtract y1, which is +3. On the bottom, we're going to have x2, which is 1, and then minus -2. And we're going to get -3 minus 3 is actually -6. And not negative. 1 minus negative is actually a plus, so this is 1 plus 2, which is 3. And of course, always reduce your fractions. And so we know that -6 divided by 3 is actually the same thing as -2. So your slope is -2 for part B. Then we're going to go on to the next one. And my x, here's my n. My x coordinate is -1, -2, -4. And then the y coordinate is -1, -2, -3. And then the x coordinate over here is 1, 2, 3. And the y coordinate is -3. So we're going to label x1, x2. This is y1, y2. And then we're going to get our slope. So we're going to go y2, which is -3, minus y1, which is also -3. On the bottom, we're going to get x2, which is 3, minus -4. And you're going to get -3, and then this is negative, that's plus. So you're going to get -3 plus 3 is 0. And on the bottom, you're going to get negative, which is plus. So 3 plus 4 is 7. And 0 divided by anything is going to be 0. So our slope here is 0. And then we're going to go to our last example. And in our last example, we've got 2 points, Q and R. So my Q point is going to be x is 1, x is 1, x is 2. And then the y coordinate is going to be 1. And then for R, you can barely see it over here, but for R, we're going to have -1, -2. Well, the x coordinate is still 2. But the y coordinate is going to be -1, -2, -3, -4. So we label our points, x1, x2 over here. This is y1, this is y2. Always staying consistent when we're labeling. So then we're going to get our slope is going to equal y2, which is -4, minus y1, which is 1. And on the bottom, we're going to get x2, which is 2, minus x1, which is 2. So -4 minus 1 is -5 on top, and 2 minus 2 is 0, and that's on the bottom. Now, this is very important. A lot of times, students think that -5 divided by 0 is 0. We already had that situation in the previous, in part C. This is undefined. This is very important. The slope is undefined, okay? So basically, when you're doing slope, you could have a positive slope, which is part A. You could have a negative slope, which is B. You can have a 0 slope, and that happens when there's no change in y. See how the line is horizontal? There's no change in y. Y is always the same. So it would make sense that the top would be 0, and 0 divided by anything is 0. But in the case of the horizontal, there's no change in x. The x coordinates are always the same. It's a vertical line. And so because the x coordinates are both 2, then the bottom is going to be 0. And whenever there's a 0 on the bottom, that's division by 0. And we can't divide by 0. It's undefined. So the slope is not 0. It's undefined. And we can summarize that information for you here, where we have a positive slope. You read a graph from left to right. So a positive slope is, the line is going up when you go from left to right. Negative is going down. You have your 0 where it's not going anywhere, and then the undefined case where it's vertical. Okay, so I just want to remind you about that. So right now we want you to try this do-it-yourself question. There's A, B, C, D. In this case, you were fortunate. You don't have to extract the points from a graph. They've already given you the points. But again, I would remind you that it's very important that you label. And remember, no change in y means 0 slope, and no change in x means undefined slope. Okay, so now we're going to go to example 2, where we're talking about rate of change. And I mentioned earlier that's basically synonymous with a slope. So here we go. It says, a pilot flies a plane from Columbus, Ohio to Orlando, Florida. After half hour, the plane reaches its cruising altitude and is 620 miles from Orlando. Half an hour later, the plane is 450 miles from Orlando. How far was the plane from Orlando 1.25 hours after takeoff? Okay, so what we've done is we've graphed, or there was a graph given actually in this problem, and it's over here. So what we have in here is already some of the information. We know that 0.5 hours, they are 620 miles from Orlando. So for the X, we have 0.5, and the Y, which is the distance away from Orlando, is 620. And then we also know a half an hour later, so a half an hour later will be 1, so 1 hour. So we've got this point is 1 hour, and at that point, they're 450 miles from Orlando. And now what we're trying to figure out is trying to predict or know 1.25 hours. So we have here going by quarters, this is 0.25, 0.5, 0.751, this is 1.25. We're trying to figure out what this value is right here. And you can estimate from the graph that it's going to be around 3 something, but we want to figure out exactly what that's going to be. So we're going to start by using our slope to find the rate of change with the points that we already know. Okay, so we know, well, first of all, let's backtrack real quick, and let's write down our information. This is going to be very, very important. Okay, so we know that when X is 0.5, the Y value is 620. We know that when X is 1, the Y value is 450. Okay? Now what are we trying to find out? We want to know when X is 1.25, and we don't know what the Y value is. That's the question. Okay? So, first thing we need to do is calculate our slope. And so we're going to label this x1, this one's going to be x2, and then we're going to label the y's. This is going to be y1, we've got to be consistent, this is going to be y2. So that means that my slope is going to be 450 minus 620, and then for the x's, we're going to get x2 is 1 minus 0.5, and we're going to get our slope. 450 minus 620 is negative 170, and 1 minus 0.5 is 0.5. So negative 170 divided by 0.5 is negative 340. So that is our slope, negative 340. Now we're going to use this information to kind of work backwards, okay? And I'll show you what I mean right now. Instead of using this as x2, y2, I'm going to go ahead and like cross this out. We already found that. We're now going to come over here and call this x2, y2, okay? And we have a formula that says m equals. We already know that m equals negative 340. So we're going to work backwards, and we're going to plug 340 in the place of m. And then our formula says to go y2, but we don't know what y2 is. That becomes our variable. We don't know what y2 is. But we do know what y1 is. y1 is 620 from before. And then on the bottom, we know what x2 is. It's 1.25. And we know what x1 is from before, 0.5. And now we're going to solve this equation, basically going backwards, right? So we're going to go negative 340 equals y2 minus 620. We want to keep our y2 blue here. And then 1.25 minus 0.5 is 0.75. Then what we want to do is multiply both sides of the equation by 0.75 so that these 0.75s will cancel, leaving us with y2 minus 620 on this side, on the right side. And on the left, we're going to take 0.75 multiplied by negative 340, and we're going to get negative 255. Our last step is to add the 620 to the other side. so that we can get y2 by itself. So 620 minus 255 is 365. Remember earlier, when we looked at our graph, we kind of estimated that it was going to be 300 and something. And now we know that it's actually 365, so our answer makes sense and our estimate made sense. So after 1.25 hours, they will be 365 miles away from Orlando. Awesome. So now you can try this example, and then we are going to go on to our next big thing here. All right, so our next little guy is dealing with parallel and perpendicular lines. Parallel and perpendicular. So we have symbols for parallel and perpendicular. So two things I want you to know about parallel is that basically if two lines are not vertical, okay, they're not vertical, they're like slanting lines, two non-vertical lines will have the same slope if they're parallel. That's the only way. If they have the same slope, equal slope, they will be parallel. And then again, all vertical lines are going to be parallel to each other. So that's parallel. And perpendicular is two non-vertical lines with product of slopes that is -1. Now, some of you might be used to saying negative reciprocal. That's why I put over here AK, negative reciprocal. In other words, if one line has a slope, oops, that's not a good color. If one of your lines has a slope of 2/3, for example, then the second line would have a slope that is the negative reciprocal. So it would be negative, this one's positive, and then you flip it over 3/2. But this is still the same thing. Product of slopes is -1. Because if you multiply the two slopes, if you take 2/3 and multiply it by -3/2, you will get -1. The 3's will cancel, the 2's will cancel. 1 times -1 is -1. So it's the same thing. A negative reciprocal, sorry about that. A negative reciprocal is the same thing as flipping it over and multiplying by -1. So there you go. Okay, so we're going to have an example right now. And if you hear some noise, don't get too paranoid. Just about 5 minutes away from being done, and my class is going to be coming in, but don't worry about it. Okay, so here we go. Determine whether A, B, and C, D are parallel, perpendicular, or neither for A, 1, 1, B, -1, -5, C, 3, 2, and D, 6, 1. Graph each line to verify your answer. So what I'm going to do is the first thing I have to do is identify the points that are in play, okay? I need to find the slope of AB, and I need to find the slope of CD, and then compare them. If they're the same, then it's parallel. If their products are -1, then it's going to be perpendicular. And if it's neither of those cases, it's going to be neither. So I need to find the slope of AB. So I'm going to start with AB and call this X1 and call this one X2. We're going to call this Y1 and Y2, and I'm going to find the slope. The first slope is going to be -5 minus 1 over -1 minus 1. So I'm taking Y2, -5, minus Y1, which is 1. X2 is -1, minus X1, which is 1. -5 minus 1 is -6, and -1 minus 1 is -2. And a negative divided by negative is positive, and 6 divided by 2 is 3. So that's my first slope. My second slope is going to be the same thing. I'm going to come over here now. I'm doing C and D. I need to find the slope of C and D. Call this X1, call this X2, call this Y1, call this Y2, and do it all over again. So M2 is going to equal Y2, which is 1, minus Y1, which is 2, divided by X2, which is 6, minus X1, which is 3. 1 minus 2 is -1, and 6 minus 3 is going to be 2. So this time my slope is -1/2. Okay? Now when I multiply, obviously they're not the same. Okay? 3 and -1 are not the same. But we don't, and I guess it's possible that you might think that it's perpendicular. So let's just try that. If it's perpendicular, then 3 times -1/2 should equal -1. But actually 3 times -1/2 equals -3/2, which is not negative 1. Therefore, this is neither. This is a case of neither. And then we are going to graph this so that we can verify our result like they said. So what we're going to do is we're just going to take our points. Sorry about that. So we're going to take 1, 1, which is A. Here's 1, 1. And we're going to take negative 1, negative 5. So here's negative 1 and negative 5. And we are going to graph this line like so. Nice and easy like that. And then we're going to take C and D, which is 3, 2. So 1, 2, 3, 2 is right about here. And 6, 1. So we're going to go 1 to the 6, and 1 is right about here. And we're going to graph that line just like that. So, as I said, we're going to verify if these guys are perpendicular or not. So it looks like I made a mistake right over here because I'm looking at my graph and they look really perpendicular. Guys, it's not complicated. Go around the camera. I'm recording. Please be quiet. So we got 1 minus 2 is negative 1. 6 minus 3 is not 2. 6 minus 3 is 3. So sorry about that. And that gives us negative 1/3. And when I come over here and multiply, I am actually going to get the 3's to cancel. And I will, in fact, get negative 1. And so these are, in fact, perpendicular lines verified by my graph right there. Alrighty, so now you can try this example, and then we're going to do one last example while my class gets started on their homework very quietly. Alrighty, so example 4, let's see here. It says, graph the line that contains A, negative 3, 0, and is perpendicular to CD with C, negative 2, negative 3, and D, 2, 0. I really want it to be extremely quiet in here. Okay, so the first thing we know is that we're going to definitely start our graph. You want the line to contain negative 3, 0. So I need to find that point, negative 1, negative 2, negative 3, 0 is right there. The problem is that I don't know what my next point should be. When I graph a line, I have to have 2 points. So what's going to happen is we're going to want this line to be perpendicular to CD. Well, in order for it to be perpendicular to CD, we have to know what the slope of CD is. So that's where we're going to start. I'm going to take CD, label it, x1 over here, x2 over there. We're going to go with y1 over here and y2 over here. It's amazing how lame people can be sometimes. Alrighty, so the slope is going to equal y2, which is 0, minus y1, which is negative 3, divided by x2, which is 2, minus x1, which is negative 2. So remember, negative, negative makes positive. And here again, negative, negative makes plus, so that's 2 plus 2. So our slope is 3/4. But they said that they want me to be perpendicular to CD. So that means that my slope needs to be the negative reciprocal of that. So the slope that I'm actually looking for is m equals negative 4 over 3. Okay? And right now I want to pause and just remind you that slope is basically rise over run. And if the top number is positive, you go up. If the top number is negative, you go down. And if the bottom number is positive, you go to the right. And if the bottom number is negative, you go to the left. So what this is telling me is that I can write this in 2 different ways. You can choose to attach the negative to the top, because negative 4 divided by positive 3 is negative 4/3. Or you could leave the 4 on top positive and make the bottom negative 3. because again, positive 4 divided by negative 3 is also negative 4/3. The only thing you can't do is put negatives in both places, because if you did negative 4 over negative 3, then that would be a positive 4/3 and would not be the same thing as negative 4/3. So you don't want to do that. So now we're going to use this slope to graph the second point that I need. Again, I'm going to start with the point I was given, which is negative 3, 0. And because I have negative 4/3, I'm going to go down 4 units. So I'm going to go down 1, down 2, down 3, down 4. Okay, I'm going down 4 units. And then the 3 is positive, so that means I'm going to go right 3 units. So that's going to be 1, 2, 3. I'm going to be right here. Okay, but I also want to show you how this going backward things works. What if I wanted to try this way? The 4 on top is positive, so I'm going to go up 4. So I'm going to go up 1, up 2, up 3, up 4. And then the negative 3 tells me not to go right, but to go left. So I'm going to go 1, 2, 3, right about there, and put my point there. So I can either go down 4, right 3, or up 4, left 3. Any of those options will give me the same line, which is, bam, right there. Okay? So now what I need you to do is do yourself number 4. And once you have done that, you will have completed your notes for this lesson. And I will see you in class. And thank you for watching. And sorry that my class is a little loud today.